Good evening. This is assignment number 34, and it looks like I'm going to be able to go through most of this with you so that you can see how these problems are done if you're having any struggles or issues with that. So area of triangle and trapezoid, and here are the formulas in case you didn't notice. That's the formula for the area of a triangle, and here's the two formulas for the area of the trapezoid. Number one asks for the area of a triangle. We're given the base and the height, and we're asked to find the area. Area equals 1/2 base times the height. The base is 6 units. That means units right there. And the height is 8 units. 1/2 times 6 is 3. 3 times 8 is 24, and that's the area of the triangle for number 1. Number 2. For number 2, with the triangle, we're already given the area, and we're asked to find the height. Again, area equals 1/2 base times height of a triangle. The area is 8, the base is 6, and we'll leave h for the height. So that's what we've been given. Now we can ask ourselves, what is the height if the area is 8 and the base is 6? Well, let's simplify this a bit. 1/2 of 6 is 3. Now we solve for h by dividing both sides by 3. H equals 8/3. And that would be the height for number 2. Number 3. Now this one I did in class. I'll go ahead and go through it again just in case you missed it. We have a right triangle. So I'm going to draw a right triangle. And I'm told that with this triangle, the hypotenuse is 10 and one of the legs is 6. And I'm asked to find the other leg. Let's call it x. And clearly we can see we can use the Pythagorean theorem here. 6 squared plus x squared equals 10 squared equals. So that's x squared equals 100 minus 36. X squared equals 64. X equals 8. So the other leg is 8. Well, we needed that other leg to find the area of this triangle, because for the area of a triangle, we need 1/2 times the base times the height. So now we know the base is 8 and the height is 6. We don't use the hypotenuse. We use the legs. We could have used this as the base and this as the height because they're perpendicular to each other, but I usually use the bottom side when I'm doing these, because I think of this as the base. 1/2 times the base times the height is equal to 24. And that's the area of the triangle. The last question is asking for the altitude to the hypotenuse. What is the length of the altitude to the hypotenuse? So this goes back to a chapter when we dealt with geometric mean and similar triangles. Here is our right triangle, and we know this is 6 and this is 8, and the altitude to the hypotenuse is going to be the perpendicular segment. Does this look familiar? We will need to pull apart the 3 triangles. The theorem says when you drop a perpendicular or an altitude from a 90-degree angle in a right triangle, that this altitude breaks and divides this triangle into 3 similar triangles. So I'm drawing them now. I put the right angle here in the lower left, short side, short side, short side. I'm separating this triangle into 3 similar triangles. And now very carefully labeling all the parts. So this is 10. This whole thing is 10. So this is 10, this is 6, this is 8. Now on the medium triangle, we don't know the length of the short leg. That's the altitude we're actually looking for. Let's call it x. That's the altitude we're actually looking for. And the hypotenuse is 8, and we don't know the length of the long leg. We know it's less than 10. We'll just leave that for now. Hopefully we won't need to use that. Now the small triangle, the short leg here, we don't know it, but the long leg we know is x, and the hypotenuse for the small triangle is 6. Labeling these is like the main part of this kind of a problem, labeling these correctly. Now we have the big triangle, the medium triangle, and the small triangle, and we're solving for x. Is there a proportion that we can use with these three similar triangles? Yes, there's a couple of triangles that we could use and use proportions for. I could say that x is to 8 as 6 is to 10. There's more than 2, there's several. Or I could say x is to 6 as 8 is to 10. You'll notice that the proportions will end up cross multiplying the same numbers here. We get 10x equals 48, and we'd get the same thing here, 48 equals 10x. Dividing both sides by 10, we get 4.8. X equals 4.8. If you want to leave it as a fraction, that's 48 over 10. Dividing both by 2, we get 24 over 5. So you could get 24 over 5, or x equals 4.8. And that is the length of the altitude to the hypotenuse. 4.8 or 24 over 5. Number 4. An isosceles triangle. I'd like to draw it. It really does help. The two legs are 13 and 13, and the base is 10. Now this is an isosceles triangle. I'm asked to find the height of it. I'm going to drop down the height. Remember that the height of an isosceles triangle, when drawn from the vertex to the opposite base, will divide this into two equal parts when it's drawn between the two legs here. So these two are 5 each. If I take out half of this isosceles triangle, this is 5, this is 13, I can find this height by using the Pythagorean theorem. 13 squared equals 5 squared plus h squared. Looking for h here. It's a right triangle. I can use the Pythagorean theorem. So that's 169 minus 25 equals h squared. That's 144 equals h squared. H equals 12. Now if I went too quickly skipping a couple steps, then do it on your own. Pause it and make sure you can use the Pythagorean theorem to solve for h there. We're asked to find the height, and it's 12. Now, to find the area of this entire triangle, I use the formula 1/2 base times the height. The base is 10, and the height that we found using the Pythagorean theorem is 12. Half of 10 is 5. 5 times 12 is 60. The area is 60. Number 5. Now we're given an equilateral triangle. An equilateral triangle, of course, you know, has all same side lengths. And every angle is 60 degrees.